7, day 3, we're going to talk about similarity in right triangles. So we know about similarity in triangles, right? They have congruent angles and sides that are what? Proportional. Okay, so we have angles that are congruent and sides that are proportional. Today we're going to talk about similarity in respect to right triangles. So all the similarity we're going to do today is going to pertain to right triangles. Now, right triangles have 90-degree angles. They have a lot of special characteristics that other triangles don't have. And also similarity among them will have some special circumstances that we can use and different formulas we can use that we cannot use with other similar triangles. So, how many triangles are in this figure right here? You also have the figure on your paper. There are 3 total triangles, right? And they're all right triangles. So we've got this right triangle ADB. We've also got the little right triangle over here, BDC, and then we've got the entire triangle ABC, right? So, in the diagram, so let's write a similarity statement. Triangle ABC, which is, I'm froze, I'm sorry. Triangle ABC is similar. Now, what angle in triangle ABC, what angle is the right angle? B, right? Is similar to triangle. Well, let's do this left triangle. What's the angle that's the right angle in this one? D. So D is going to be, and then it's short leg. So my short leg was BC. So my short leg right here is BD. Right? So I need to have BC going up with BD. So D is the middle one. So it's going to be ADB. Is similar to triangle. What's the right angle in the little triangle? Angle D, and that short side is DC, right? BDC. So all those triangles are similar to each other. And remember similarity statements, we want to get congruent angles with congruent angles, proportional sides lined up with proportional sides. All right, so this one says, identify the similar triangles in the diagram. Well, I just did that. Well, this is a different picture. Never mind. And sketch them so that the corresponding sides and angles have the same orientation. What do you think that means? Yeah, they're all flipped around going the same direction. Okay, so I'm just going to start with the big one being exactly like it is. So the big one is PQR. So my Q is my right angle. Okay? So I just copied it exactly the way it was already oriented. So what I'm going to do is take these smaller right triangles and flip them around to where they're in the same direction. So I'm going to start with this one right here. Okay? So do y'all see that RQ looks like my shorter leg? Okay? So when I draw it, I need to make sure the shorter leg kind of goes right here in the same direction. Does that make sense? So in this triangle right here, the one to the furthest to the left, what's the right angle? S. So I need to put S in the bottom corner. And this one's slightly smaller than the first one. And what angle up here makes the short leg of this triangle? Q. And then P stays where it is. Oh, I'm trying to write my Q. Touch screen is touchy today. Stop. And then there's P. So there's the medium-sized triangle. And then the one to the right, the windless one, S is my right angle again. Y'all agree? So I'm just basically flipping around those triangles. And what's the short leg go with this little triangle? R. So R goes up on top because that's where the short leg was. And the long leg goes to Q. So y'all see what I did? It's like I just took original triangle, then I flipped around the other ones to where they were facing the same direction. Okay, but make sure when you do that, the right angle stays the right angle, and then the short and long legs go with their corresponding parts. Okay, so since these are similar triangles, we are going to set up proportions to find missing sides and angles. Now, I'm not going to lie, this can get a little bit confusing and complicated, so it's important to label everything and know if you're talking about short legs, long legs, or hypotenuse. Okay? So on number 2, we're finding x. Well, x is this altitude right here. And I can't really tell if x is the short leg or the long leg in this triangle, but in this triangle, it's definitely the short leg. You agree? So I'm going to call that little triangle on the inside triangle A. Just name it triangle A. That makes it a little bit simpler. And the whole outside triangle here, I'm going to call that the big triangle. Okay? So I've got triangle A. I'm setting up a proportion. And then the big triangle. Okay, so we said X is the short leg of triangle A. Do y'all agree? Y'all agree? And so what else do I have of that triangle? Do I have the long leg or the hypotenuse for triangle A? Hypotenuse. So to set up my proportion, I want to use short leg and hypotenuse. Got my words all mixed up. Okay, so this is just helping me set up my proportion. So what's the short leg of triangle A? That's my X. Over what's the hypotenuse of triangle A? 12. Equals. What is my short leg of the big triangle? 9. Okay, if you can't tell by looking, 9 is definitely smaller than 12. They've labeled all of those, right? So 9 over, what's the hypotenuse of the big triangle? 15. So do y'all see how labeling everything helps? So you can kind of put it in a matrix there. Kind of looks like a Punnett square from biology, right? Okay, it's not, has nothing to do with it. But anyway, that's how we set up a proportion. So that way you can keep it strict. I'm doing short legs and short legs, hypotenuse and hypotenuse from triangle A and the big triangle. Okay, now it's a proportion, so how do we solve it? Cross multiply, good. X times 15 is 15x equals what's 12 times 9? 108, and we are going to round here. Divide by 15, and x equals what? 7.2. Did they give me any units? No, so just 7.2. Okay. So any questions on number 2? Labeling helps. Trust me. Trust me. All right, look at number 3. It's kind of a similar setup. I do know all the legs and hypotenuse of the big triangle, so that might be helpful. Which one do I want to let be triangle A? The little triangle on top or the big one on the bottom? Me too, because it looks like I can tell for sure that that's the short leg and the hypotenuse, right? Okay, so I'm going to let that one be triangle A. Okay, so I've got triangle A and the big. So I'm solving for X, so I need to put X in there somewhere. Is X the short leg or the long leg of triangle A? Short leg, looks like the short leg. So I'm going to do short leg over, that 21 is what on triangle A? The hypotenuse. I'm going to do short leg over hypotenuse again, since I know all 3 terms or all 3 sides of the big triangle. Okay, so y'all help me fill in those 4 parts of that. I'm going to do a little smaller so my fraction isn't so big. I know, fill in all 4 parts of my proportion. So what's the short leg of triangle A? X. What's the hypotenuse of triangle A? 21. Equals, what's the short leg of the big triangle? 11.2. And what's the hypotenuse of the big triangle? 23.8. Y'all with me? Anybody question about the setup? So labeling helps, trust me. Cross multiply. X times 23.8 is 23.8x equals, what's 21 times 11.2? 0.12. And then you divide by 23. Oh, sorry. And then divide by 23.8. And x is approximately, because I'm rounding, about 9.9 units. Yeah. Okay. Questions? Okay. This one looks like I can set up similarly. All right, which one do you want to be triangle A? The one to the left or the little one to the right? Now, if we use the little one to the right, I'm going to use long leg, right? Y'all see that? Because X is the long leg of this little one. Does that make sense? Okay, so you're just going to have to look at it and tell. So if y'all want to do the one to the left and keep it short leg over hypotenuse, you are welcome to. On your practice, you might not have a choice. Okay, so just keep that in mind. So I'm going to do triangle A to the big triangle. And X is my short leg. And what else do we have in triangle A? I don't have the hypotenuse. What's the hypotenuse? Oh, yeah, that's the hypotenuse. Sorry, yes. I don't have the long leg of triangle A, do I? All right. So 24. Good. So the hypotenuse of A is X. The short leg of A is X. The hypotenuse of A is 24. The big triangle, what's the short leg of the big triangle? 7. What's the hypotenuse of the big triangle? 25. So cross multiply, X times 25 is 25X. And then 24 times 7 is 168. Divide by 25. X is approximately what? 6.72-ish? Okay. All right. So that's how you find missing sides of right triangles when they are similar. All right. You set up proportions. Label, label, label. I promise it helps. Okay. So let's talk about the geometric mean. It's pretty easy once you memorize it. Okay. So the geometric mean of two positive numbers, A and B, is the positive number X such that this proportion happens. A over X equals X over B. So it's this proportion. A over X equals X over B. Well, we can simplify this a little bit, right? So to simplify that, we can cross multiply, right? What's X times X when I cross multiply? And what's A times B? AB. Good. And another way I can write it, if I want to get rid of the square and just offer X, what would I do to both sides? Take a square root, right? So just plain X equals the square root of A times B. This is what we're going to use if we have to find the geometric mean of just two numbers. It's pretty easy. Now I've erased all my squares from the board, so we are going to simplify some radicals. Okay? So if it says find the geometric mean between the pair of numbers, that means of 6 and 30, that means you're just going to take the square root of 6 times 30. That's it. It's simple. Square root of 6 times 30. You do have a quiz problem like this tomorrow. You are not going to tell me a decimal. Okay, we're going to simplify the radical. So what is 6 times 30? It is 180. So the square root of 180. Now, we had our perfect squares on the board. They're no longer on the board. So what do you think is the largest perfect square that goes into 180? 13 is not a perfect square. 9 is not the largest one. Because that's 9 times 20, and 20 has a perfect square that goes into it. Excuse me, I'm choking. Is 36 the largest? How do you know if you get the largest or not? You work the table, right? 1 squared is 1, 2 squared is 4, 3 squared.
9.
Next one.
16.
Then what?
25.
Then what?
36.
Then what?
100. 121. 144. 169. 196.
Y'all get quiet.
So if we're looking for 9, we need to come into the plug in for 8. What are we saying with 8? Not 0. We're plugging in 6, right? Why would we plug
It's 19 squared. 20 squared, 400, and it keeps going, right? Okay, so to know you get the largest, you know 180 is in between these two numbers, right? And then you can just plug this in, this in, this in, this in, this in until you get one that goes into it, right? So what's the first one that you would come to that goes into it? 36. So 36 is the largest. All right. 36 times what equals 180? 36 times 5. And what's the square root of 36? So this is 6 radical 5 is the geometric mean. Okay? 16 and 28. So you take the square root of 16 times 28. It's a pretty big number. What is 16 times 28? 448. All right. I don't think 400 goes into it. Y'all tell me what you think. Is that the largest one? 448 divided by 64. It's 7. So that's a prime number. So if you know if you divide it by it and get a prime number, then it's got to be the largest. Right? Okay. So because prime numbers won't simplify anymore. So that's the square root of 64 times 7. And what's the square root of 64? 8. So that is 8 radical 7. Y'all try the next one. Geometric mean of 12 and 50. Oh, that's easy. Dang it. That should have been the first example. What's 12 times 50? Square root of 600. What's the largest perfect square that goes into 600? 100 times. And what's the square root of 100? Raise your hand if you got 10 radical 6. Any questions? Easy peasy. Okay. So we have just practiced finding a geometric mean, and it turns out that you can use geometric means to help you find some sides in similar right triangles. So we've got a geometric mean theorem, which is also called the altitude theorem. Do y'all know what an altitude is? Yes, it's how high it is. So it's basically a perpendicular drop from a right angle perpendicular to another segment. Okay, so like this BD right here is the altitude. Y'all see that? Okay, so The length of the altitude is the geometric mean of the lengths of the two segments. So basically, this is the altitude, BD. So BD squared equals the two segments that it crosses. So it crosses AD and DC. So the length of AD times DC. So the altitude squared equals the length of the two segments created when it's dropped perpendicularly. Okay? It's the two segments that it splits, multiplied together. Okay? So this is actually really simple, and it's on your quiz tomorrow. So what's my altitude? X, 8, or 12? X. So you're going to say x squared equals what splits that segment into a part that's 8 and a part that's 12, right? So x squared equals 8 times 12. And what is 8 times 12? So x squared equals 96. Well, how do I get rid of the square on the x? Square root, right? Square root of both of them. So x equals, now what's the largest perfect square that goes into 96? 16 times what? 16 times 6. And what's the square root of 16? So 4 radical 6. That's it. So you do the altitude squared equals the two little segments that is split by it. Okay? Now number 9's a little different. How is number 9 a little different? Yeah, it doesn't give you this length, but it gives you the length of that whole hypotenuse. Right? So how do I get the length from just here to here?
Subtract 5.
Yeah, 37 minus 5. So some of them you might have to do a little bit of arithmetic to get the segments that you're supposed to get. So you're splitting the hypotenuse with the altitude. Does that make sense? Okay. So it's going to set it up altitude squared. So x squared equals what? Yep. 5 times 32. What is 32 times 5? X squared equals 160. And then how do I get just x? Square root both sides. Good. So x is going to equal, well, 16 goes into it. 16 times 10, right? Square root of 16 times 10. What's the square root of 16?
4.
So 4 radical 10. So you split the hypotenuse with the altitude and multiply those and set it equal to altitude squared. Okay? Number 10's a little different. How is number 10 different? Yeah, the x is one of the legs. It's part of the hypotenuse, isn't it? It's part of the hypotenuse. So which one gets the square? 18, x, or 15? Yeah, the altitude gets the square, and the altitude this time is 18. Y'all see that? So you're going to set it up a little bit differently. So 18 squared equals x times 15. Yeah, I'm going to rewrite it. Yeah, I'm going to rewrite it 15x, but yes, it's the same thing. All right, so what's 18 squared? 324 equals x times 15, like we just said, is 15x. And this one is nice because you don't have to simplify a radical. So you just divide by 15. So 324 divided by 15, and you can give me a decimal on this one. What is that? 21.6. So if you have to simplify a radical, don't give me a decimal. But if you don't have to simplify a radical, you can give me a decimal. Okay? Okay. How do you think we can do number 11 to find x? There's a couple of things you could do.
You could put in x as the missing length, multiply by 30. No.
Well, x is actually the whole hypotenuse. You could do x minus 30, but that's gonna get a little complicated in there. What I would probably suggest you do right here is come up with another variable for this side. Does that make sense? Make up another variable. Y sounds good. Okay. And then after we get y, couldn't we get x by adding 30 to it? Does that make sense? Okay. So yeah, we eventually have to get x, but first we've got to find this little side. So just give it another variable. So how do I set that up using the altitude theorem? 21 squared equals 30 times y. What's 21 squared? I mean 441? 441 equals 30y. Now how do I solve for y? Divide by 30. I'll get about 14.7. All right, so there's y, but I need to get x. So how do I get x? Yeah, you add them, because 14.7 is this little part, right? And 30 is this little part. So together, x is the big thing, the whole hypotenuse. So 30 plus 14.7 is what? 44.7. Final answer. Does that kind of make sense? Okay. So any questions about the geometric mean or the altitude theorem? Altitude squared equals the two little segments broken up by the hypotenuse. Okay, the next one is slightly more, I guess, I want to say complicated, but it's really not. And this is the leg theorem. Okay? The leg theorem. So, for the leg theorem, look at this triangle right here. So AB is a leg, is it not? Right? AB is a leg of the big triangle. So for the leg theorem, you take the leg, so I'm going to say that's AB. So AB, and you're going to square it. You're going to set it up like a geometric mean again. And this time you're going to multiply by the adjacent part of the hypotenuse to it. And the hypotenuse. So the whole thing times that part. Okay? So that leg equals this leg of this other triangle times the hypotenuse of the big. So it's going to be AC, which is the whole hypotenuse, times the other little leg that it touches, AD. So these are kind of harder to see. So on number 12, X is a leg, right, of the big triangle. So you're going to say X squared equals the whole hypotenuse times this leg closest to it. Okay? The whole hypotenuse times this leg closest to it. So what's the length of the whole hypotenuse there?
26.
26, good. Times what's the length of the leg closest to it? 24. So X squared equals 26 times 24. What is 26 times 24? 624. So X squared equals 624. Square root. What is the largest perfect square that goes into 624? Well, I don't think it's going to go anything till it gets 256. That don't work. Oops, sorry, y'all. $196. 624. Hate when it's a big one. Sometimes you just gotta play with them. Y'all hit one, holler. Let me do 16. If you do 16, 39 goes into it. And there's no perfect squares that go into 39, right? Because it's 3 times 13. Those are both prime. So that actually works. 624 is 16 times 39. And what's the square root of 16?
4.
4. So that is 4 radical 39. And yeah, you would think with a big number like 39 that it would simplify. But like I said, 39 is 3 times 13, which is both primes. Right? So since that's both primes that go into it, it's only numbers between 1 and 39, then it will not simplify anymore. Okay? All right, good job. So number 13, we're using the leg theorem again. 13, we're using the leg theorem again. So x is a leg, right? Right? So x squared equals, what's the hypotenuse of the big triangle? 12. What is the length of the leg that's closest to the original leg? It's 5. Very good. Do y'all see why it's 5? You don't use that one, you use the one that's adjacent to it. So the one that's closest to it. So what is 12 times 5? Equals 60, square root. What's the largest perfect square that goes into 60? It's 4 times what? 15. So x equals what? 2 radical 15. All right, good job. We're actually going to stop there. So y'all can cross out number 14 and number 15 on your notes. And that's the end of notes for today. We're going to practice now. Have a good day.